My name is Nurazila binti Ghazali. My metric number is 261646. Water supply. What is water supply and why it is important to building? Water supply system are facility for collection, transmission, treatment, storage, and distributing water for household, commercial, established, industry, and irrigation, as well as public need include firefighting and street flushing. The availability of potable water is probably the most important of all municipal service. People depend on water is used for drinking, cooking, cleaning, eliminating waste, and other household use. Water supply system must also meet requirement for public, commercial, and industrial activity. In all cases, the water must fulfill both quality and quantity requirement. Water supply from the main to the building is through one of the following system depending on the pressure of the water and timing of the supply. The important is there are two types of supply system. Direct supply system. Supply of water is directly given to various floors with required pressure for sufficient hour. This is only useful for the building which is not more than 2 floors. Separate connections to be provided for domestic and non-domestic requirements. Indirect supply system. Used generally when the pressure in the main is not sufficient. The water is pumped directly to the overhead storage tank, and from there, the water is supplied to different floors by the gravity. The water is stored in the underground tank, and from there, water is pumped to the overhead tank, and then it is supplied to different floors by gravity. There are two types of water sources. Water is in constant circulation power by the energy from sunlight and gravity in a natural process called the hydraulic cycle. Water evaporates from the ocean and land surface is held temporarily as vapor in the atmosphere and fall back to the earth's surface as precipitation. First is surface water, is the residue of precipitation from the rain and melted snow, called runoff, where the average rate of precipitation exceeds the rate at which runoff seeps into the soil, evaporate, or is absorbed by vegetation bodies or surface water such as stream, water, and lake are formed. The total land area that contributes surface runoff to a river or lake is called watershed. Drainage basin or catchment area. The volume of water available for municipal supply depends mostly on the amount of rainfall. It also depends on the size of the watershed, the slope of the ground, the type of soil and vegetation, and the type of land use. Second is groundwater. Water that infiltrates Earth's surface become groundwater, slowly seeping down into extensive layer of porous soil and rock called aquifer. Under the pull of gravity, groundwater flows slowly and steadily through the aquifer. In low area, it emerges in spring and stream. The value of an aquifer as a source of groundwater is a function of the porosity of the geologic stratum or layer of which it is formed. Water is withdrawn from an aquifer by pumping it out of a well or infiltration gallery. An infiltration gallery typically includes several horizontal perforated pipe radiating outward from the bottom of a large diameter vertical shaft. Wells are constructed in several ways, depend on the depth and nature of the aquifer. Wells used for public water supplies, usually more than 30 meters deep and from 10 to 30 cm in diameter, must penetrate large aquifer that can provide dependable yields of good quality water. Both surface water and groundwater eventually return to the ocean, where evaporation replenishes the supply at atmospheric water vapor. Wind carry the moist air overland, precipitation occurs, and the hydraulic cycle continues. Problem of water sources in Malaysia. There are 4 problem water sources in Malaysia. First, industrial waste. Industry produce a tremendous amount of waste which contain toxic chemical and pollutant, causing air pollution and damage to our environment and us. They contain harmful chemicals include lead, mercury, sulfur, nitrate, asbestos, and many others. Many industries not having a proper waste management system drain the waste in the fresh water which goes into canal, river, and later into the sea. The toxic chemicals may change the color of water, increase the number of minerals called eutrophication, change the temperature of the water, and pose a severe hazard to water organisms. Second is sewage and wastewater. The sewage and wastewater that is produced in each household are treated chemically and released into the sea along with the fresh water. The sewage water carried pathogen, a typical water pollutant, other harmful bacteria, and chemicals that can cause a serious health problem and thereby disease. Microorganisms in water are known to cause some of the very deadly diseases and become the breeding ground for creatures that act as carrier. This carrier inflict this disease into an individual via various forms of contact. A typical example would be malaria. Urban development. As the population has grown exponentially, so has the demand for housing, food, and clothes. As more cities and towns are developed, they have result in increasing use of fertilizer to produce food, soil erosion due to deforestation, rise in construction activities, landfills as more garbage is produced, increase in chemical from industry to produce more materials. Chemical fertilizer and pesticide. Chemical fertilizer and pesticide are used by farmers to protect crop from insects and bacteria. They are useful for the plant growth. However, when these chemicals are mixed up with water, they produce harmful pollutants for plants and animals. Also, when it rains, the chemical mix up with rainwater and flow down into river and canal, which pose serious damage for aquatic animals. Technology that can be implemented to solve the problem of water contamination in Malaysia. First, membrane technologies that can be remove such difficult industrial pollutants. Several types of synthetic semi-permeable membrane can be used to block the flow of particles and molecules while allowing smaller water molecules to pass through under the effect of hydrostatic pressure. Pressure-driven membrane filtration systems include microfiltration (MF), ultrafiltration (UF), and reverse osmosis (RO). They differ basically in the pressure used and pore size of the membranes. RO systems operate at a relatively high pressure and can be used to remove dissolved or inorganic compounds from water. Both MF and UF systems operate under lower pressure and typically used for the removal of particles and microbes. They can provide increased assurance of safe drinking water because the microbial contaminant can be completely removed by the physical barrier. Low pressure membrane filtration of public water supply has increased significantly because of improvement in membrane manufacturing technology. Smart river monitoring using wireless sensor network. The benefit of using the Internet of Things (IoT) for river monitoring are pretty straightforward. Install IoT sensor along the river and at intersection of major drains. Connect the sensor to a central system that reflects real-time data in a visual form. Enforcement agency can take action immediately once the sensor detects anomalies. This way, it can help give quick alert before the water enters the reservoir. For instance, the sensor can be placed in the middle of the river or on riverbank. A door monitoring IoT sensor can be placed below bridge, on lamp poles near the river or in dedicated poles. Meanwhile, sensor placed in pipe can detect leakage. Other locations include manholes, into which some irresponsible parties dump to toxic waste, which then end up in major river. Dissolved air flotation (DAF) systems are designed to remove suspended solid (TSS), biochemical oxygen demand, and oil and grease from a wastewater stream. Contaminants are removed through the use of dissolved air in water solution produced by injecting air under pressure into a cycle stream of clarified DAF effluent. This recycled stream is then combined and mixed with incoming wastewater in an internal contact chamber where the dissolved air comes out of solution in the form of micro-sized bubbles that attach to the contaminant. The bubble and contaminant rise to the surface and form a floating bed of material that is removed by a surface skimmer into an internal hopper for further handling.